The last thing, or there are two more things I want to cover here. And so let's take a look at a picture of an imaging system. Again, let's make note of our sign conventions, that images are positive to the right side and objects are positive to the left side of the lens. Any rays that start at an object point will meet again at an image point. This happens to be true in the ideal case, whether the point is above the optical axis, as shown right here, and it happens to meet here below the optical axis. We'll talk more about this in the next class. But the equations I have that relate the object image distances in my equations are right here. I also know that the focal length is equal to this, so with a simple substitution, I've related my object distance and my image distance by the focal length. So 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. That means if I'm given a lens of focal length f, even if I don't know the index of refraction, R1 and R2, as long as I'm given the focal length, I know how far away from my lens an image will be formed if I know how far away the object is. And this is a critical thing because this is how we start to understand the geometry of imaging systems. In other words, if I put a candle or a light out here at this distance, SO, and I know the focal length of my lens, and I hold a piece of paper at a distance SI from the lens, there will be an upside-down image of the candle flame at that point. And more about images in the next class. Really, to conclude, the chapter also talks about different types of lenses, and this is a little bit confusing because lenses are classified by 3 different things, and there's sort of, as shown in this figure, overlap between the different types of lenses. Negative lenses, let me go ahead and get a black pen, I'll try to follow along with my color convention here. Negative lenses, if parallel rays of light come in, the rays of light diverge or spread out on the other side. For positive lenses, which are shown here in red, as rays of light come in, they converge, and they're going to focus down onto the optic axis on the right side of the lens. So lenses can be either negative or positive. For real optical materials, things you're going to encounter, negative lenses also tend to be concave. In other words, they have cup-shaped surfaces. A concave lens has a cup-shaped surface. So notice all the lenses here have cup-shaped surfaces. A lens can be either double concave with 2 concave surfaces, 1 concave there and 1 concave there, or what we call plano-concave with 1 concave surface and 1 flat surface. Similarly, lenses can be convex, which means instead of bowl-shaped surfaces, they have sort of hump-shaped surfaces. They're rounded outward like that rather than rounded inward. And again, you can have double convex lenses or plano-convex lenses with 1 hump shape and 1 flat shape. Notice a plano-concave lens, or excuse me, a plano-convex lens could also have that shape. The orientation really doesn't matter. The other type of lens is what we call meniscus lenses that have 1 concave surface and 1 convex surface. A meniscus lens is negative if there's more curvature to the concave side, and positive if there's less curvature to the concave side and more curvature to the convex side. And I'm getting my tongue twisted just trying to say all of this, so hopefully you're following along. So let's take a look at this lens right here. It has the overlap of meniscus and negative, so I would call this a negative meniscus lens. This guy right here has the overlaps of 3 groups. It's a positive lens, and it's plano-convex. So this would be a positive plano-convex lens. This guy over here is the overlap of negative, concave, and double. So I would call this a negative double concave lens. You'll notice that concave and convex and positive and negative are sort of the same thing, but it's good to describe a lens as negative or positive. So again, what's this guy called? A negative plano-concave lens. And now you have an idea of lens naming conventions, at least for real materials. And again, the derivation is in a second mini-lecture you can watch if you want to understand the mathematics and the simplifications we need to make to understand how the rays of light bend through a real optical system.